Oh, thank you. Well, I'm happy to have taken public transportation to get here this morning. I came down on the Gold Line from the Mount Washington area and then by foot. But I do drink a lot of coffee, so hopefully I haven't negated my sustainability credits. All right, I'm really excited about the project that's up here. We just completed planning phase modeling of green infrastructure implementation at a redevelopment site in San Francisco. It's about 42 acres, so it's very highly urban. I don't have results to report today because it's in the feasibility stage, but it would have a significant impact on the combined sewer system and the watershed in terms of volume reduction. So stay tuned for next time on that. We're a water resources firm and also specialize in green infrastructure. My background is in water resources engineering. I originally wanted to go into environmental science, but my mom, who's a biologist, said, hey, we need an engineer in the family. Why don't you go that direction? But the lovely thing about green infrastructure is it lets us combine the engineering and the science aspect of water management. I've got quite a number of slides, so I'm going to move through the case studies relatively quickly. You're more than welcome to ask questions once we get through it, but I just want to give you a flavor of quite a few different projects. This one is a flood control demonstration project and basically includes retrofit. There's a flood control channel off to the left that's a traditional, it looks like the LA River, concrete line from the 50s. This involves retrofitting backslope swale as a vegetated swale and then a future phase as bioretention. With a plant palette that allows for safety, visibility, easy maintenance, but also will provide aesthetics because there's a nearby walking path. So it will have monitoring and then hopefully will become part of the MS4 program for the community. The second project is here local. It's at the LA County USC Medical Center, and this was from an environmental impacts report, so it's very high-level planning. But we basically looked at 84-acre redevelopment and what was recommended in the master plan, which was some green infrastructure implementation. I mean, frankly, it's not overly aggressive. It's a reasonable percent of the site. They had recommended porous pavement, which is shown in blue, as well as some bioretention to meet stormwater management goals and criteria. And so we looked at, we went through some detailed swim modeling, looked at design storm events, and also looked at a continuous simulation modeling of about 40 years of rainfall record, and looked at what would the runoff from the site be, what are the maximum annual peak discharges, how does that compare to the site, before it redevelops. And so the good news was that the green infrastructure implementation, as expected, is really going to increase the performance of the site, make it much more sustainable, lower water use, much more infiltration, and reduced runoff. And so part of that goal is improving surface water quality into the receiving stream, which this ends up draining to the LA River. A couple of commercial examples from Northern California, from the Sacramento area. These are both demonstration projects at community centers. Very small sites, about an acre or less. Again, very detailed swim modeling, looking at the hydrologic performance, basically trying to return these redeveloping sites to a pristine, undeveloped historical condition. And so our hydrographs really show that we are close to mimicking an undeveloped site condition. So we're significantly improving existing conditions. And then a lot of these projects, because it's still a fairly new tool, it's a great opportunity for communities to meet their MS4 requirements for public education and outreach. So a lot of times we'll do interpretive signage. This one illustrates how a rain garden works, where you've got the stormwater capture on the surface layer, some pre-treatment by the mulch, and then filtration through the system. Excellent tool with biological, physical, and chemical processes. And then we can get into the details of how does each bioretention area, each rain garden area, each piece of porous pavement, how does it function in terms of filling up and draining out with water? Are we meeting vector control requirements? And we can see from the graphs that the reservoir below, I believe this is the rain garden, so the surface fills up and drains out pretty quickly, and that's what we want it to do. Same thing with the bioswale. So again, showing the effectiveness of those native grasses with the deep roots, the interaction of the mycorrhizal fungi for the pollutant removal. Our porous pavement, these were type D or clay soils, very low hydraulic conductivity rates. Our previous speaker talked a lot about hydraulic conductivity. So green infrastructure works remarkably well on type A and B, sandy and well-drained soils, but it can also function well on C and D, more clay-like soils. We just have to modify it with underdrains. In this case, we have a raised underdrain to force storage and some infiltration over time. Second site for the same client, also a demonstration at a community center. This one demonstrated an underground manufactured product to retain the water. This type of system can also be used to collect and store and then repump out for landscape irrigation. Here we are under construction. Again, looking at not just what happens in a design storm, which is important for flooding and water quality, but also what happens over that 40-year period of record. How's it going to affect the stream health, hydromodification of the stream, and water quality over the long run. And so we're finding excellent performance in terms of returning the site to more of a pristine, undeveloped condition. A little bit of accumulation of leaf litter on the porous pavement, that type of thing. We want to get that vacuumed up or swept up to reduce maintenance so we don't have clogging from the organics. Nut grass, I'm not even going to go into that. It's kind of horrible, horrible weed, but really requires perseverance or shading it out with vegetation. Porous asphalt parking lot. Moving to the Bay Area to City of Oakland Fire Station number 1. We've got a system where it was actually more economical to use permeable pavers in the fire driving lane than traditional pavement because of the structural needs. But this system will be maintained by the firefighters themselves, so they're probably not going to bring in a vacuum truck to clean the pavement over time. So we've designed in some redundancy where there's a slot drain that will direct any runoff from the driveway into an adjacent bioretention cell. There it is right after it was planted. This is at one of my former residences. Cisterns, always an excellent tool for public education. A little hard to put on a roadway project, but we can do underground storage, and it can be excellent tools at transportation-related facilities and sites. The overflow from these goes out to a gray water combination system called a banana basin or a mulch basin, which uses the laundry to landscape method, completely legal in the state of California without a permit. Back to the Sacramento area. This is another redevelopment site. In total, it will be more than 1,000 acres, but it's a former gravel mining area right adjacent to a creek. So it's basically being recovered. A lot of the sand drying beds will create considerable topography on the site. But the first phase is about 230 acres. Very significant implementation of LID and green infrastructure. Basically all the turquoise facilities, and those are all essentially some form of bioretention or vegetated swales. So it's been kept very landscape-based, it's more residential, major thoroughfares are pretty expansive with very large vegetated swales. There's a lot of walkability, public transit, a community farm, so it's got a little bit different feel than the real commercial, hardcore urban projects. Again, very detailed modeling with the SWIM model, looking at the performance of each type of LID facility, making sure that they're all draining out at a reasonable time. And then this is tiny print, I apologize, but basically this slide is in here because when you have larger scale operations and maintenance, the cost per square foot or per acre go down considerably as compared to just trying to maintain one small, say, rain garden. So there's a lot of economies of scale we're finding. Moving to the Gulf Coast area, City of Houston, Green Streets project funded by a EPA grant through the state. Basically, it was planned as a capital improvements project, but then instead of doing traditional curb and gutter, it was incorporated to have a monitoring section that was traditional curb and gutter, an additional control section that was left as is, and then the Green Streets section, which was a couple blocks. So pre and post monitoring. This is in a significantly gentrifying and redeveloping area, so very challenging in terms of the land use changing dynamically throughout the project. And since there's no real zoning, we couldn't really predict where the redevelopment, multifamily, and dense residential driveways would go in, so we had to work around those constraints. We wanted to do something like street planters, used it a lot in Portland, but it didn't really keep with the character of the neighborhood. And then again, if you don't know where a driveway is going in, it's difficult to have these reconstructed. So we kept it more to rain gardens at intersections, similar to this, but smaller scale. And then also decided to try out a manufactured product to do some independent monitoring. Originally, we specified the Filterra product. The contractor petitioned and was approved to change to a Contec product. So the overall watershed, if you will, draining to the outlet was modeled, but we were a very small portion of the overall watershed. So while we expect to have very good performance for the street being converted itself, we don't really expect to affect the entire watershed. And that's essentially what our peak flow comparison showed for the 2-year event, which is about 4 inches for a 2-year 24-hour, and the 10-year event, which is about 8 inches for a 24-hour storm. Good peak flow reduction with very limited LID implementation. We were at 3% or less of the total drainage area of the street, but showing quite a large percent reduction. The overall watershed drainage areas, were about the same as before, slightly reduced. So this was good news. Detention was not required. A lot of times detention will be required, or inline detention in a storm drain, to make sure there are no impacts on the receiving system. In this case, the low impact development took care of that need. But you can see with the larger event, these are also type D clay soils, low hydraulic conductivity and infiltration rates. You can see the hydrographs stay up a little bit longer in the rain garden. So, it's taking 36 hours to drain out versus, 24 hours or so. So it is rainfall depth dependent as well as soils dependent. We had a great planting list. I was really pleased with it. Our landscape person did an excellent job. Beautiful plantings selected. We'll get to those photos in a bit. Unfortunately, the contractor did not plant per the planting plan. They used some of the plants, but not in the right location. It was ultimately decided not to have them replant. So they did go off the planting list, but it's just a lesson learned in terms of planning for construction phase services and having the budget available to make sure things get done appropriately. Here we are under construction. You can see one of the tree boxes installed. Rain garden at one of the corners of the intersections. You can see faintly there's some grass in there that's, not alive. So that really needs to be, maintained and replaced out. We ended up providing a pretty long punch list for the contractors to go back out and fix. But they got the mulch in there, so that's good. The plants were at least from the list. And the plants that they did end up planting will be fairly aggressive over time, and so we'll get pretty good coverage, which is going to help. Weeds are a big problem in really tropical-like environments, so it will help with the shading and the weed suppression. So you can see heavy sediment loads. So what that means is we may see some premature clogging of some of these facilities, but if they're capturing the sediment, then that's a good thing. That they're doing their job. So maintenance is really, really critical. We prepared an operations and maintenance plan for the project, which city staff will be implementing. All right, if you're interested in modeling or determining the performance of green infrastructure, we worked with Cal State Office of Water Programs. This can be used around the country. It's not just California specific. There are gauges from California, but if you have a design storm depth, you can use it for a project pretty much anywhere. And that's a web-based tool on their website. Back to the San Francisco Bay Area. This is a bay-wide tool that basically uses GIS to weight various factors like soils, depth to groundwater, environmental constraints, proximity to transportation right-of-way, those type of factors to identify good locations for various green infrastructure tools. So this is our bioretention. Once everything was considered, the green areas were recommended as ideal. Now it can be used in other areas than the green, but from a high-level planning perspective, that's what the tool's intended to do. So we did some watershed modeling on a creek in the Sonoma Creek watershed and found very good reduction in peak flow as compared to existing conditions. But existing is very agricultural, rural, undeveloped, and we really wanted to know, well, what if this was a urbanized watershed at 60% impervious cover? What would our performance be? And we found that it was better. So, of course, you can do the same amount of green infrastructure and get better performance in urbanized areas. Then it becomes a cost optimization question. It's more expensive to build these types of BMPs and features in a highly urban environment than it is in an undeveloped environment, but we see higher benefit. So the current phase of the project is a master plan for the Bay Area for green infrastructure, but it includes detailed modeling and calibration, both hydrology and water quality, for a large watershed in the city of San Jose. And one of the goals of this phase is to do cost optimization, so we can determine most cost-effective areas to place these tools. Back more locally, beach community, city of Santa Monica, they have a large number of BMPs. Most of them are focused on their transportation infrastructure in the road right-of-way, at maintenance facilities, city yards, bus barns, and so forth. But their maintenance plan has specific photos of what the BMP looks like. And that might not sound like that big of a deal, but for an agency that has hundreds of these in place, when we went out and did the field work, sometimes they're actually hard to find. Now, for a porous asphalt parking lot, pretty easy to find, but trying to locate a hydrodynamic separator or some other device, it was helpful for their staff to have photos. And then finally, the Riverside County Flood Control and Water Conservation District site. This is an amazing site. If you ever make it out to the city of Riverside, they're at 1995 Market Street. It's one of my favorites in the country. Pretty much demonstrating all types of low-impact development tools, redevelopment of their site. It's just very beautifully done. And a little bit of a twist. They have highly permeable soils, but the idea was, well, what if you can't achieve any infiltration? What if we have contaminated soil, high groundwater, impermeable clays? So they actually installed liners under quite a few facilities. But preliminary monitoring results are still showing good hydrologic performance, primarily due to storage and some evaporation. So a bioretention area, we prepared, we've got a great graphics and communications person. This project actually won some national communications awards for the signage, as well as many, many local and sustainable project awards. Vegetated Swale, but they've got a nice walking tour you can go through. Planter box, nice porous growing media. You can see the rocks.